Hey guys, welcome to our next note video. So first thing I want to do is just remind you of that Pythagorean theorem. You may want to write it just at the top of your note sheet so you have it in case you need it, that a squared plus b squared equals c squared, because that's really important for all that we're doing yesterday and today. And next, let's talk about Pythagorean triples. All right, so if three sides satisfy the Pythagorean theorem, then they form a right triangle. We call that a Pythagorean theorem. So basically today what's going to happen is we're going to be given three different sides, and we have to kind of decide, hey, is this going to be a Pythagorean triple or not? Okay, so we're going to plug them in. The biggest thing you need to know is that A and B are going to be the two shorter ones, and C is always going to be the biggest one. Okay, so let's go ahead and take a look at what that would look like. So let's start off with, first of all, this number 1. So what we want to do here is we want to go ahead and plug it into the formula. So we're going to take first the two shorter sides, and we're going to call those A and B, and then the longer side is going to be C. So we have 20 squared plus 21 squared is equal to 29 squared. Now, when you're doing this, I do want you to show a lot of work so that way I can check it. So 20 squared is going to give me 400. 21 squared is going to give me 441. And 29 squared gives me 841. So now I'm going to add those two together, and I get 841 is equal to 841. So yes, this is a Pythagorean triple because we can plug those in and we can get the right triangle out. Let's take a look at number 2. So again, our two shorter sides are going to be A and B, and our longest side is going to be C. So we're going to plug that in. We're going to take 8 squared plus 10 squared, and set that equal to 12 squared. Well, 8 squared is 64, 10 squared is 100, and 12 squared is 144. So let's go ahead and let's add these two together. 100 plus 64 gives us 164. And that's supposed to be equal to 144. Uh-oh, it's not. They're not equal. So they're not equal, so then we have to say no. This isn't a Pythagorean triple because those aren't equal. So again, I want to make sure you're showing all of that work so that you can prove to me why it is or is not a Pythagorean triple. Okay, next, let's take a look at 9, 12, and 16. So I'm going to get it set up for you, and then I want you to plug it in and calculate it out for me. So this is my A, my B, and my C. So I have 9 squared plus 12 squared is equal to 16 squared. So I want you to go ahead and plug that in and see if you can get it to be a Pythagorean triple. Make sure you write yes or no. Let's take a look at number 4. So number 4, we have our A, our B, and our C. So then I have 10 squared plus 24 squared is equal to 26 squared. So then 10 squared is 100. And then 24 squared is going to give us 576. So again, this is where your calculator comes in handy, and 26 squared is 676. So then 100 plus 576 is 676. And yes, that is equal to 676. So yes, this is a Pythagorean triple. It works out beautifully for us. Let's take a look at number 5. So this is what's called a 3, 4, and 5 triangle. So you're going to see this a lot in geometry. So let's see if it's a Pythagorean triple. So we have our A, our B, and our C. So we have 3 squared plus 4 squared, and that's going to be equal to 5 squared. Oops, 3 squared plus 4 squared is equal to 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25. So 9 plus 16 is 25. Is 25 equal to 25? Well, yes, indeedy do. It is. So yes, this is a Pythagorean triple. I'm going to go ahead and have you guys try number 6 on your own. See if you can get that in with the Pythagorean theorem, or using the Pythagorean theorem, see if these are all equal. Here's your A, here's your B, and here's your C. Let's take a look at number 7. So number 7, we're going to get a little bit of bigger numbers. So I have A, B, and C. So 9 squared plus 40 squared has to be equal to 41 squared. So 9 squared is 81 plus 1,600 has to be equal to 1,681. When you add those two together, you get 1,681 is equal to 1,681. And yes, that is a Pythagorean triple. Go ahead and try number 8 on your own. Remember, I do want you to show work simply because by showing work, you can prove to me that it is a Pythagorean triple. Let's take a look at your favorite thing in the whole wide world, which is word problems. I know you love them dearly, so I'm glad we're going over them. So let's take a look at number 9. It says, what is the area of triangle ABC? Well, in order to get the area of a triangle is 1/2 base times height. Well, here we have the base, but we don't know the height. So we have to use the Pythagorean theorem now to get the height. So 12 is going to be my A, 20 is my C, so I need to find B. So this is going back to what you did yesterday. So we're trying to calculate that missing leg. So I have 12 squared plus B squared is equal to 20 squared. Okay, so then I get 144 plus B squared is equal to 20 squared. 20 squared, which is 400. So now to get B squared, I'm going to do 400 minus 144. So then I get B squared is equal to 256. Now to figure out what just B is, I'm going to take the square root. And it just so happens that we don't have to write this one as a simplified radical. We can just take the square root and we get 16. So now I know that the height of this is 16. So now I can use this area formula. So now I know that area is equal to 1/2 times the base and times the height. So now I'm going to multiply all those out. Well, we can look at this as 0.5 times 16 times 12. So I'm just going to plug that into my calculator and see what answer I get, and I end up getting 96. So the area of that triangle is 96 units. Let's take a look at 10. A square shopping center has a diagonal walkway from one corner to the other. If the walkway is about 70 meters long, what is the approximate length of the side of the center? Well, this one's kind of confusing. So let me draw a square shopping center. And here's my walkway, cutting all the way across. It helps if you make sound effects. So then we're going to say that that there is 70. So now we have to figure out the side lengths. Well, now we have to think about what we know about a square. Here are some things we know about a square, that all sides are the same. So if this is length A, then this is also length A. So what we notice from here now is that we can actually pull out a triangle. So now we have a right triangle, because if it's a square, then this has to be a right angle. So now we have a right triangle, and we have A, and 70. Okay, so now let's figure that out. To use the Pythagorean theorem, I'm going to do A squared, and I'm going to use A squared again instead of B because they're the same side. Well, if you think way back to Unit 3, if two terms have the same exponent, you can add them together. So then here we get 2A squared is equal to 70 squared. Oops, I forgot the squared here. So let's go ahead and first figure out what 70 squared is. So then I get 2A squared is equal to 4,900. That's 70 squared. So now I'm going to take and I'm going to divide both sides by 2. And I get A squared is equal to 2,450. Now to get A, I'm going to take the square root of both sides. But we're not quite done. Okay, first thing is we end up getting A is equal to the square root of 2,450. Now, at no point in this unit do we want to leave a radical unsimplified. So we're going to go ahead and simplify that down. So we're going to break down that radical. We're going to do 25 here, and we're going to do 98 here. So 25 we can break down to 5 and 5. 98 I can break down to 2 and 49. 49 I can break down to 7 and 7. So remember, think back to when we started this unit. If you don't know what goes into it, just start dividing it by numbers and see what pairs you can find. So we end up getting A is equal to the square root of 2 times 5 times 5 times 7 times 7. Let's pull out some pairs. So I have a pair of 5s I can take out, and I have a pair of 7s I can take out. So then I have A is equal to 5 times 7 on the outside, and then radical 2 left on the inside. 5 times 7 is 35, radical 2, and this right here is your final answer. So for your final answer, you get 35, radical 2. Make sure you label it. Okay, it says it's about 75 meters long, so this is 35 square root of 2 meters. Because remember, whenever you do a word problem, you want to label it. Now let's take a look at this one. This one can look really, really confusing. So if the perimeter of a square is 160 units, square one is 160 units. So 160 units, and there's 4 sides. So I'm going to take 160 divided by 4. When I do that, I get 40. So each of these side lengths are 40. Then I'm going to take 120 for square 2 and divide that by 4, and I get 30 for each of these. So now that interior triangle, I have this. I have 40, and I have 30, and I have C. Now C is this side length right here, and I don't know what it is, so I'm going to try and figure that out. So I'm going to use the Pythagorean theorem because that's going to help me get my third side length. So I have 30 squared plus 40 squared is equal to C squared. So first thing I do is 30 squared and see what that is equal to, and I get 900. And 40 squared is 1,600, and that's equal to C squared. So when you add those together, you get C squared is equal to 2,500. So we're going to take the square root of each side. And when we take the square root of each side, we end up getting a whole number. We end up getting 50. So the side length of that triangle then here is 50, which means that this side length here is 50. And since it's a square, each of these sides are 50. So now we need to go and answer what the question is actually asking, which is what is the perimeter of square 3? So we need to add 50 plus 50 plus 50 plus 50. And when we add all of those together, we get 200 units, okay? Because that's the label it originally gave us up here, was 200 units. Okay, let's take a look at these ladder problems. You're going to see these a lot. So let's draw us a nice picture. So a fireman has a ladder. Okay, let's draw that ladder. So it's going, here's my ladder, boop, 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 boop. Wow, that worked really well, didn't it, guys? Okay, so that's my ladder. No judgment, right? It's 150 feet off the ground. So here's the house that's on fire. Okay. Okay, that's the fire. So it's leaning up against the house. Now it's telling us that the building, it reaches a point of the building that is 80 feet above the ground. So the point that it reaches the building is 80 feet. So this right here is 80 feet. It tells us the ladder is 100, and we want to see how far away it is from the building on the ground. So that actually gives us a right triangle. A height of 80, a hypotenuse of 100, and some miscellaneous value down there. So we're going to go ahead and plug that into the Pythagorean theorem. So 80 is going to be my A, and then I don't know B, and then my C is 100. So 80 squared gives me 6,400, plus B squared is equal to 10,000. So now to get B squared, I'm going to subtract 10,000 from 6,400. So the next thing we want to do is subtract those out. And when we do that, we end up getting that B squared is equal to 3,600. So now we're going to take the square root of both sides. And here's a little hint. Do you see how this number right here is a perfect square? That means that this is going to have a square root. So you take the square root of 3,600 and you end up getting 60. Last thing we need to check is our label, which is feet. So that right there is your final answer for number 12. So I'm going to have you do 13 on your own. It's going to be really similar. Let me set up the drawing for you. So first we have our ladder going up the building. Here's my building here. It says the ladder is 52 feet long. So the ladder itself is 52 feet. And the foot of the ladder is 20 feet from the foot of the tree. So here's my tree right here. I'll make it beautiful for you guys. There's my tree. And it says that it's 20 feet from the tree. So this length right here is 20 feet. This is 50 feet. And you want to find how tall it is hitting the tree. So go ahead and use the Pythagorean theorem to calculate that out for me. Go ahead and bring me a completed note sheet when you're done so you can start your worksheet. Alrighty, bye.